So I'm just going to do a few examples again just to make sure you get some extra practice on this. So again, this is factoring out the expression using the greatest common factor. So I'm going to do this one with you, and then I'm going to give you one to try. So the first thing is 20 minus 12. So we want to find the largest number that can go into 20 that can also go into 12. So you can kind of go through your factors and kind of come up with something that they both have in common. So if I start listing them out, so I'm just going to say them out loud instead of writing them. 2 goes into both of them. 4 goes into both of them. That's actually the only 2. So 4 would be the biggest one. So you're going to put 4 on the outside because that's your greatest common factor. And then you have your parentheses. Now we're going to fill in the parentheses with what you would multiply 4 by to get these 2 original numbers. See how there's a minus here? I'm just going to put the minus right in the middle. So 4 times 5 is 20. So that's my first number. And then 4 times 3 is 12. So that's my second number. So that's your answer, 4 times 5 minus 3. So let's see if you can try one by yourself. So you're going to have to erase this, I guess. Okay, so let's try one for you guys. So pause and try this one. You're going to find the GCF, put it on the outside, put your parentheses. On the inside, you're going to write what you would multiply them by to get the original number. So pause and try that one. Okay, so now for this one, it's kind of the same exact thing. They're actually giving us an expression that's already done, and they want us to tell which one of these is not equivalent. So an easy way to do that is write down all of the factors of 16 and 24 that they have in common. So they all have a 1 in common. They both have a 2. 2 goes into both of them. Let's see, 3 goes into 24, but not into 16. 4 goes into both of them. 5 does not. 6 does not. 7 does not. 8 does. Let's see, and 10, 12, nope, that's going to be it. So those are the only 4 factors that 16 and 24 have in common. So remember, your greatest common factor is what goes on the outside of the parentheses. It doesn't matter which way it's written. So like for this one, it's written backwards. The common factor is on the outside. Still the same exact thing. So we want to look at the common factors and figure out which one doesn't belong, kind of like Sesame Street. So for this one, they have a 2 on the outside. 2 is a factor, so that should work totally fine. For this one, they have a 4 on the outside. 4 is a common factor, so that should work fine. This one has 6 as a common factor. 6 is not a common factor, so that means that part C is the one that doesn't belong. It's not going to factor out to give you the same thing. And then if you actually want to check it out, if you did it, 6 times 3 is 18x, not 16x, so you know that it doesn't work. So that one, not going to work. All right, so see if you guys can try this one. It's just asking you if this is equivalent to this. So if you actually did the distributive property to this, so remember the distributive property, you're multiplying that outside number by everything on the inside. So do that out to the 7 and see if you get this. And if you do, they're equivalent. If you don't, they're not equivalent. So pause and try that one. Okay, this is tiny. I don't really know why. All right, so you receive a discount on each book you buy for your electronics. Let me move this. For your electronic reader, the original price of each book is X dollars. You buy 5 books for a total of 5X minus $15. Factor the expression, and what can you conclude about it? All right, so if I factor this, that means I need the greatest common factor for 5 and 15. So the largest number that goes into 5 that also goes into 15 is 5, so I'm going to pull that out. Do my parentheses. Okay, now I have to figure out what I can multiply 5 by to get the originals. So 5 times x is going to be 5x, and then 5 times 3 is 15, and then the minus just goes in between. So there's my factored expression. What can you conclude about the discount? Well, you bought 5 books, and this is showing me that the price of the book minus 3, so your discount is $3. You're saving $3 every single time. Okay, so you're going to factor the expression, and whatever is being subtracted from the variable when you're done is how much you're saving. Okay, so let me see if I can give you one of these to try. So pause the video. This is the last one. So pause the video and try this one. They're already giving you the expression. You're going to factor out the greatest common factor, and whatever is left that's being subtracted from the variable is going to be your discount. So see if you can try that one.